Hi, I'm Tom Loschiavo, Education Manager here at PASCO Scientific.
And I'm Barbara Puglisi, Curriculum and Training Specialist at PASCO.
And we're here today to talk about concentration and conductivity, and we're going to use the wireless conductivity sensor. So why don't we pair that up?
First, I'm going to turn the sensor on by hitting the power button. And immediately, the Bluetooth light will start flashing red, indicating that it's ready to connect in the software.
So I'm going to go into the software, and I'm going to touch the Bluetooth icon, and I'm going to see the available devices. And this is the available device. If I have a room full of these, then they will all show up in the list, and the closest one will be on top, which makes it easy for classroom management. Touch on conductivity. Now it's in the connected devices section, and I'm going to hit done.
And on the sensor, the Bluetooth light is now flashing green, indicating that it is connected.
So what kind of experiment are we going to conduct right now?
Well, we're going to look at the conductivity of a serial dilution of this sports drink to see how conductivity is affected by concentration.
Okay. And we picked the sports drink because it's a great way to introduce the idea of concentration, and it gives students a visual cue right off the bat. And we can make measurements so we can quantify that. And we're going to do that in percents before we get into molarities. We'll build up to molarities. So let me show you what I built on the page here. I have concentration and conductivity in a table, and I have a graph of conductivity on the y-axis and concentration in percent on the x-axis. I've set this to manual sampling, so I can select each of those things, and I'll be able to see the relationship between that concentration and conductivity. So which one are we going to do first?
Well, let's start with 100%. That's what came straight out of the bottle, and that's this solution right here.
Do we need to do anything to the conductivity sensor before we start?
Yeah, it's a good practice to clean your sensor with distilled water, rinse before starting the experiment and in between solutions.
And the conductivity sensor is water resistant, so you don't have to worry about spills or splashes when you're using it with water samples, which you're going to do.
Right. Here's the conductivity of that initial solution.
So I'm going to go to my SparkView software, and I'm going to hit Start. And now here's my conductivity in the table, and it's plotting it on the graph for me. And I'm going to use the check marks here to hit Keep, and keep that sample.
And now it's ready for the second data point. We prepared these dilutions 50% at a time. So we took 50 milliliters or whatever volume of your initial solution, and we added 50 milliliters of distilled water to get a 50%.
Right, so this is very easy for students to understand right off the bat. They can understand those percentages very easily as we do this dilution, and they can see it as they're making them.
Yeah, they can see the orange is a little bit lighter each time in each solution.
And now let's check the conductivity. So it was originally around 2,200 microsiemens per centimeter, and now it's around 1,200. So 50% dilution, about half the conductivity. I'm going to hit check, and we'll try another one.
Okay, remember to rinse. And again, it was diluted, half water and half of this solution.
So now we're down to 25%. And now I was at 1,200 before, and now I'm around 600, 650, 690. And I'm going to hit check. And now I can see that line on the graph is forming a nice straight line as I relate the conductivity to the concentration.
Right, and finally the last solution.
Nice.
Yeah, we can see that linear relationship in that graph.
So the measurement's pretty stable. I can see the live reading right there. I'm going to hit check. And now I'm going to stop my data. And now if I really want to explore this relationship, I can even use the graph tools. And I'm going to apply a linear fit to see if it forms a nice straight line. We have a 0.999 R value, which looks pretty good. So we can definitely help the students understand concentration and conductivity relationship with this.
Right, and don't forget to clean your sensor before you put it away. Rinse it with distilled water and dry it, and then store it.
Right, so to learn more about the conductivity sensor and to learn more about some other experiments that you could conduct with it, please go to pasco.com/wireless. Thank you.
See you next time.